Generalized measurement system. It can be considered as a system that is used to measure the required quantity or parameter. Generalized measurement system consists of the following elements: primary sensing element, detecting element, detector transducer element, variable conversion element, intermediate modifying element, data processing and data presentation element, terminating stage element. Input signal, transducer signal, analogous to input, analogous driving signal, calibration signal, auxiliary power source optional, detector transducer stage, auxiliary power source intermediate modifying stage, indicator, recorder, controller. Most measuring systems fall within the framework of a generalized system consisting of three stages, namely detector transducer or sensor stage, an intermediate modifying stage or signal conditioning stage, a terminating or readout stage as shown in the block diagram above. Basic elements of a measuring system: Stage 1, detector transducer device. Stage 2, intermediate modifying device. Stage 3, terminating device. Senses only the desired input and provides analogous output. Modifies transduced signal into a form usable by final stage. Usually increases amplitude and power. Provides an indication or recording in a form that can be evaluated by human sense or by a controller. Types and examples. Types and examples. Types and examples. Mechanical, contacting spindle, spring mass elastic devices such as Bourdon tube, proving ring, etc. Hydraulic, pneumatic, buoyant, float, orifice, venturi, vane, propeller. Optical, photographic film, photoelectric cell, electrical, contactors, resistance, capacitance, piezoelectric crystal, thermocouple, etc. Mechanical, gearing, cranks, links, cams, etc. Hydraulic, pneumatic, piping, valves, dashboards, etc. Optical, mirrors, lenses, optical filters, light levers, optical fibers. Electrical, amplifying systems, machine, matching devices, filters, telemetry systems, etc. Indicators, displacement types, moving pointer and scale, light beam and scale, CRO, liquid column, etc. Digital types, direct, alphanumeric readout, recorders, digital printing, inked pen and chart, light beam and photographic film, magnetic recording, controllers, all types. Stage 1, detector transducer stage. The important function of this stage is to detect or to sense the input signal. At the same time, it should be insensitive to every other possible input signals. For example, if it is a pressure signal, it should be insensitive to acceleration. In the measurement of strain, the strain gauges should be insensitive to temperature. Automobile tire gauge used for measurement, checking air pressure of an automobile tire. Construction consists of a cylinder, a piston, a spring resisting the piston movement, and a stem with graduation. As the air pressure bears against the piston, the resulting force compresses the spring until the spring force and air forces are balanced. Stage 1, detector transducer stage. Here, the piston and cylinder combination make up the detector transducer spring other element. Other examples refer figure. Stage 2, intermediate modifying stage. As the name itself indicates, this lies between stage 1 and stage 3. The main function of this stage is to modify the detected transduced information so that it is acceptable to the third or terminating stage. The important function of this stage is to increase either amplitude or power of the signal or both to the level required to drive the final terminating device. It may also perform selective filtering, integration, differentiation, etc. as required. Generally, these will be electrical or electronics circuits. Examples: amplifiers, mechanical levers. Stage 3, terminating stage. This stage provides an indication or a recording of the signal in a form which can be understood by a human being or a control system. This is done by data presentation element. Here, the information output may be obtained in different forms such as pointer moving over a graduated scale, in digital form as in computers or as a trace on an oscilloscope, etc. An example of a generalized measurement system is a simple bourdon tube pressure gauge. In this case, the pressure is sensed by a tube of elliptical cross section which undergoes mechanical deformation. Cross section tends to become circular. The gearing arrangement amplifies the displacement at the end of the tube so that a relatively small displacement of the tube end produces a greater revolution of the center gear. The final indicator stage consists of a pointer and scale arrangement which when calibrated with known pressure inputs gives an indication of pressure signal acting on the Bourdon tube. In 1849, the Bourdon tube pressure gauge was patented in France by Eugene Bourdon. It is still one of the most widely used measurements for measuring of the pressure of liquids and gases of all kinds, including steam, water, and air, up to pressures of pounds per square inch, 100,000 pounds per square inch. Eugene Bourdon founded the Bourdon Sedgwick Company to manufacture this invention. Instrument characteristics, behavior. The instrument and measurement system characteristics can be divided into two distinct characteristics: static characteristics, dynamic characteristics. Static characteristics pertain to a system where quantities to be measured are constant or vary very slowly with time. Normally, static characteristics of a measurement system are those that must be considered when the system or equipment is used to measure a condition not varying with respect to time. Dynamic characteristics pertain to a system where quantities to be measured vary rapidly with time. These are there are many phenomena which can be conveniently described by the static response, while on the other hand, there are phenomena which can only be reported by dynamic response. The overall performance of a system many a times can be evaluated by semi-qualitative superposition of static and dynamic characteristics.